Hey, workshop students. I was asked about a quiz one. I thought I'd make a video here to help you. This is a quiz you're working on tonight. So I'll wait a couple of hours here before I send it out, or maybe I'll just wait till the morning. But here is an answer to the last quiz one that seemed to bother a few people, so I thought I would kind of work through this one. And so it says something like this. It says, an object is traveling in a circular path. So let me make part of a circle. Let me put the object, say, right here. And it says that, let's see, object travels in a circular path with a radius of. So let's see, maybe I'll put a little dot here for the center of the circle, and I'll just put right here R for radius. Now, being that it's a quiz, I think you guys all get different numbers, but as I look it up, my number comes out to be 7.01, but you probably have or had a different number than this. Okay. Now, I'll keep reading. And at a speed of 6.1 meters per second. So let me just pretend this is the object going around, and maybe just to make it stand out, I'll draw in green, but tangential to the circle would be the velocity vector. So it has a magnitude, at least in mine, of 6.10 meters per second. Okay. I don't know if I made the center of my circle real well. Let me improve it there. Because right here it says there is an angle of 60 degrees between the acceleration vector and the velocity vector. Well, this is really getting to the heart of this problem, is that you have two accelerations going on, a component that is tangential and a component that is radial. Maybe to make, again, stand out, I'll change to kind of this. Well, I don't have a blue in here. Why don't we do a blue? What do I do with my blue pen? Okay. And so the acceleration that makes it change direction points right to the center of the circle and is equal to v squared over r, the two quantities they gave us. So we actually know that number, or we can find it in a second here. Now, the other component, the tangential piece, is the part along the motion, or it could be opposing the motion. If it's opposing, it's slowing down. If it is in the same direction, it's speeding up. And I know it's going to be the same direction because here's what it's saying. And so I'm going to make kind of a little grid here. You could probably, do this is the y direction and this is the x direction. Because if you add the x and y components, you get the total acceleration vector. So maybe to label them, I'll say, okay, this is the acceleration in the radial direction. This is the total acceleration. This is the acceleration in the tangential direction. And you see it's 60 degrees. That's how I knew the tangential one had to be in the direction it was moving, because if it was pointing the other way, the total of the two would be something like this, and we'd have to get a number greater than 90 degrees. So that's kind of how this plays out. All right, so our problem is, and it says here, find the speed at which the object is increasing, its rate. Wait, how does it say? The speed of the object is increasing at a rate of. All right, so here begs the question. It does say the speed is increasing, but which one do they want here? Do they want the total acceleration? Do they want the radial acceleration? Do they want the tangential? And they want the tangential. It's the tangential piece that changes the speed. So this is change in speed. Whereas the radial one is change in direction. And of course, the total is a combination of the two. And so they don't want the total, and they don't want the radial one. They want the tangential one. Okay, so this is the one that we want. And remember, then this is the one that we know. I say that because I guess there's a lot of ways that we can kind of look at this. Maybe I will do this. If I look at the tangent of 60 degrees, okay, tangent, and then kind of got this triangle here, would be the opposite. So that's the radial direction over the tangential direction. And the radial one, as we said, is v squared over r. So why don't I get a number, at least for the numbers I have? The v squared would be 6.1 squared, and I would divide it by the radius, 7.01, and so this would be 5.31. So 5.31. And I'm looking for this, the tangential. And I know the tangent of 60 degrees. That's pretty easy to put in the calculator and get 1.732. So moving things around, moving this over to here, and then taking this number, I'll just go over there and copy it, and divide it by that number, and hit enter. I would get 3.06 meters per second squared for the rate at which it's changing its speed. Okay? So that's the idea behind this problem. Hope you got it right.